Welcome back, ladies and gentlemen. Mr. Eicher here. This is the third of three videos for this lesson 3 and 4. Almost there, people. Distance learning. Almost there. So one minor correction, if you fill in the notes as you go along, which I would encourage you to do, if you go back to the very first page of these notes, I believe on this stem plot, I did not include the 8, 9, 9. I kind of got sidetracked by the gap at 7, but the 8, the 9, and the 9 should also be included there. Anyway, we all make mistakes. We're not looking for perfection. We're looking for progress. So in this last question, we've been talking about given just a bunch of numbers like this is not really that helpful. It's really hard to analyze this data. So we graph the data, we visualize it so we can make observations more easily. And we find summary statistics like the mean or the median or the standard deviation to help us communicate about this data. So this is data, this is real data. The number of unprovoked attacks by alligators on people in Florida each year for a 33-year period. So for instance, this number right here, 22, there was a certain year that there were 22 unprovoked attacks by alligators on people in Florida. My parents live in South Carolina, and I was golfing with my dad, and we were walking to the green, and there was an alligator on the green. There was water right next to the green, so we kind of had to wait until the alligator moved to be able to continue playing. That was in South Carolina. My grandma lives in Florida, and occasionally she'll have alligators kind of walking down the street in Florida. So these are unprovoked attacks by alligators. We don't know how many provoked attacks by alligators there are in Florida, but I'd encourage you, don't provoke an alligator. But even so, if you don't provoke an alligator, they might still attack you, I guess. It's kind of surprise, maybe. But anyway, here's the data that we're looking at today. So the first question, or the point of this lesson, we're going to be looking at something called a box plot. A box plot is a certain type of graphical display. We've done dot plots and stem plots. Today's box plots. And then in our last set of lessons, lesson 5 in this chapter, we'll be doing what are called histograms and normal distributions. Those are really, really important in statistics. But box plots. So first thing, we would want to order all the data from lowest to highest. Here's all the data again in one big string of numbers. And I've already listed it for us to save some time. Listed it for us from the lowest 1 attack in a year all the way to the highest, which was 24. So this is in a 33-year period. So to find the median, the position of the median, to find that from a previous video, we learned we could do the number plus 1 over 2. The number we have is 33. So 33 plus 1 over 2, that's 34 divided by 2. So we're looking for the, let's see, 34 divided, yeah, the 17th number, the 17th position. So if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 17. So the median would be 9. That is the 17th position. So the middle number is 9. So that would be a measure of center is the median. And then it says, find the median of the lower half. So if we kind of draw a line through 9 here, we have an upper half and a lower half. So the lower half, let's do that again. Let's find the median of the lower half. Well, we have how many total numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers in the lower half. So we would do 16 plus 1 over 2. That would be the, let's see, 17 over 2 is 8.5. position. So that would mean we're looking for the number between 8 and 9, the 8.5 position. So the number between 8 and 9, the 8th and the 9th position, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's right here. The number between 5 and 5 is 5. And that is called the first quartile. Whenever we do halves like this, we half at the median and then we half the lower end. Basically, we're going to divide this data set into quarters. So it's called a quartile. This is the value, 5 is the value of the first quartile. So what does it represent? We would say, since we've quartered the data, there's 25% here. There's 25% of the data here. And we haven't quartered the top yet, so we'll do that later. But what does this first quartile represent? Well, we'd say 25% of, let's see. Unprovoked alligator attacks in Florida have fewer than 5, or maybe I'll say 5 or less. Five or fewer attacks. Now we could also interpret it kind of the other way. If 25% is this way, then what percent would be that? Well, that would be 75% of unprovoked alligator attacks in Florida have 5 or more attacks. So really important there that if you're going to go 75%, you have or more. If you're going to go 25%, you're going to have or fewer for the first quartile. Also for the first quartile, the notation that we use for the first quartile is a Q for quartile and 1 for the first quartile. So the first quartile is Q1 equals 5. The first quartile equals 5. Okay, so let's find the median of the upper half for letter E. To find the median of the upper half of the data, this is called the third quartile. So we already have, we know that there are 16, I believe. Might as well count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 in the upper half. So we can go 16 plus 1 over 2, which is 17 over 2. So it's going to be, again, between the 8th and the 9th. And so let's count. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. So right in between, what number, what value is between 14 and 15? That would be 15.5. So that would be our third quartile. So Q3 equals 15.5. And let's interpret what that means in this context. So again, now we can fill in, this is 25% and this is 25%. So a quarter of the data is here, a quarter of the data is in between here, a quarter of the data is in between here, and a quarter of the data is there. So we would say 25%. I'm just going to abbreviate to attacks, maybe gator attacks, of gator attacks. Have what? Well, 15.5 is here. 25% would be that or more. Have 15.5 or more attacks. And it's okay, it's a decimal, even though an attack can't be a decimal. This is just a numerical summary. Now, if you have 75% of gator attacks, have 15.5 or less. Well, I guess the better English grammar-wise is 15.5 or fewer text. Fewer for discrete and less for continuous, but that's another lesson. So we have 25% is 15 or more. 75% are 15 or fewer. So that's how we interpret the first quartile and the third quartile. Now, the reason we use quartiles is to make a box plot, and that's our graph of the day today. So let's start with a scale, like so, kind of like with what we did with a dot plot. And on the scale, we'll label it, let's see, we go from 1 to 24. So I guess we could count by twos. It's not too much. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And this is number of unprovoked. Ooh, I almost said provoked. We don't want to provoke the unprovoked gators attack in Florida over a 33-year period. Okay. Now, to make a box plot shows 5 numbers, which we call the 5-number summary. The 5-number summary, it shows the minimum, quartile 1, the median, quartile 3, and the maximum. Now, if you're wondering, why do we jump from quartile 1 to quartile 3? Well, that's because the median is quartile 2, right in the middle. Okay, so let's graph this, these numbers. What's our minimum? Our minimum is our lowest number, which looks like 1, gator attack. Q1 was 5. The median was 9. The quartile 3 we wrote as 15.5. And the maximum is the highest number, which was 24, the highest number of unprovoked gator attacks. So to create a box plot, we're going to plot those numbers. 1. So we're going to put a vertical line at 1. We're going to put a vertical line at 5. That's a 1, that's a 5. We're going to put a vertical line at 9. We're going to put a vertical line at 15.5. And we're going to put a vertical line at 24. Now with those vertical lines, we're going to make a box. There's going to be a rectangle that has the median inside the rectangle, and Q1 and Q3 are the edges of the rectangle. So it looks like this, Q1 to Q3. You make a rectangle or a box plot, and then you have just a horizontal line that connects the minimum to the Q1 value, and then a horizontal line connecting Q3 to the maximum. And this is a box plot. This is a nice visual way of representing these. Particularly, these are really nice to use to compare multiple. Maybe you wanted to compare multiple states, South Carolina unprovoked gator attacks versus Florida unprovoked gator attacks. And it's a really nice visual to compare big data sets. But with that box plot, so probably on an assignment, you'll be provided a box plot and you'll be asked to interpret the Q1 or Q3 and things like that. Important to note about a box plot, a couple things. Box plot, we don't know how big the sample is based on a box plot. We can't tell. There's nowhere here that tells on the box plot itself that there's 33 years worth of data. We could tell it here, but we can't tell from the box plot. So that's just one thing to note about box plots. And there's other things, but we'll just leave it at that. And then our last question, I wanted to ask a question about measures of center. So this says, you're interviewing for a job. The person who is interviewing tells you that the average salary of 5 employees is $58,000. Seems like a pretty good average. Should you take the job? Well, the salaries of the people who work there are $15,000, $15,000, $20,000, $40,000, and $200,000. Which would be a better measure of center, the mean, which is the average, or the median to represent the salaries? So the reason I wanted to show you this is a really common and important use of measures of center, and really important for you to know, especially when you're taking jobs and looking at news casts about different statistics and government and politics and things like that. So this number is the mean, 58,000. What's the median pay? The median is also a measure of center. Well, the median pay would be the middle when they're lined up and they're already ordered for us. So the middle number is this one, 20,000. So should you take the job? Well, the issue is if you're only looking at this, that really overestimates how much you'll probably get paid. If you're just starting, I'm guessing they're not going to be paying you the highest in the organization, $200,000. That $200,000 is an outlier. It's unlike all the rest that overinflates the mean or the average. So really, the better measure of center to tell is the median. More salaries are closer to $20,000. So if you're ever applying for a job and you ask what's the typical salary, you'd probably ask what's the starting salary for my certain position. But as you look at colleges and as you look at different jobs, careers, often the mean is what will be reported. But that can be really deceptive because if you have a couple people that are making a lot of money in that position, you might not really get a sense of how much you're going to get paid. $58,000 would be a pretty good wage coming right out of college. Be able to pay off your college debt potentially. But $20,000, the median, what might be more likely that you get paid, would be difficult to pay your bills. So it's really important that you know the difference between the mean and median, and when one of them might actually be deceptive to what the reality is. Well, thank you for watching this video. I hope it was helpful for you. Give me a thumbs up if you like the video, or if just you like the colors in the video. Thanks again for all your hard work on all this distance learning stuff. Have a great day.